Hello everyone and welcome back. Now that we are connected to the signaling server or to our backend, let me add a comment. It's time to open the connection to media server and publish the local stream. Okay, so right here, we want to create a function named Open Media Server socket, like that. Let's add it here. To do that, we want to have a helper class named StreamPublisher. So we will take a look at what does this StreamPublisher do in a second. It's responsible to create a peer connection and connect to the WebSocket of the media server and publish our local stream to it. Let's go ahead and create this class. So it will have a constructor that will receive a private val WebRTC factory class JSON and a callback of type StreamPublisher callback class that I'll create in a second and add it down here. So simple as that. It will have two main functions. First one is start publishing. It gets the sender user ID type string and sender username type string. Let's see what's inside this one. And the last one is destroy. We will make this one later. So let's take a look what's inside our start publishing function is. We want to have two variables. The first one is media server socket. This media server socket client doesn't exist at the moment, but I'll create it in a second. And the next one is RTC clients of type RTC clients, which will be null initially. Let's go ahead inside this socket, inside the remote directory, and create class name media server socket client, just like that. I'll go ahead and copy and paste everything here to not duplicate everything we have, to avoid writing it down again. Everything it's pretty much the same with that socket IO client, but the connection is WebSocket. So we have an init function and a callback. It's going to receive the socket URL, which is the media server socket URL, and the callback, that is this function whenever the socket is open, close, connection error, and new message. And also the media server message model is totally different from our signaling server. So it has a comment, the ID, the CP, session description, candidates, and code. We are ready to use our media server socket client inside our StreamPublisher. Let's import this one here. And when we want to start publishing, first we have to connect to the WebSockets of the media server. Let's instantiate this media server socket client, pass JSON to it, and then use the init function on it. So for the URL, simply want to go to constants class and add a function named get publish stream path. It's going to be the direction of the send, so it's for publishers. Let me add this base URL since I have published inside this URL. Also, I'll add another functions, get stream path. This one is for receiving the URL. Let's go ahead and use these functions inside our StreamPublisher class right here. So I'll publish stream path and pass the sender user ID to it. Let's import this one. And for the callback, we will anonymously use the media server socket clients dot media socket callback. So let's implement the members. So right here, whenever we start publishing using this function, we create a connection to the media server socket. So when the connection is established, we want to send a signal to the media server to say, hey, we want to receive the offer. So the command is going to be request offer. We simply send this one to the server and it will generate the offer and send it back to us. So it will give it back here inside the on remote socket client new message. We want to check it here. If message dot command is equal to offer, we simply want to initialize our remote RTC client, which I'll add here. It's a private function to start creating a peer connection using that received offer from the media server. So let's use this name in its remote RTC client. It's going to get the sender user ID of type string and sender username of type string as well. So inside it, we want to use run caching and then destroy the previous RTC clients. Destroy, simple as that. And then we want to make it null. Right now it's time to re-instantiate it using WebRTC factory and create RTC clients. For the observer, we want to make an anonymous class of type myPeerObserver. For the listener, we want to also make it anonymously from the callback of the media socket server. It's going to be RTC clients imp.transfer like this, and last one for is publisher mode, set it to true because it's a StreamPublisher. So right here, let's implement the member of it. Down here, whenever a packet is ready to transfer, we simply want to use media server socket and send data to us and pass the data to it, simply like that. And up here, when we are creating the peer connection, we pass the observer of type myPeerObserver. As you can see, there are so many callbacks for states of the peer connection. So right here, I want to override some of them functions. So on ICE candidate, this one is for the time that the ICE candidate is being generated. So if you want to check if it's not null, then use the RTC clients and onlook call ICE candidate generated and pass it to it. So if you remember this one, it will add the candidate inside my message model and prepare it to be sent to the server. Let's go back here. Another function to be overridden is on connection change, which will have a new state. So we check if new state is equal to connected like this. We want to use the callback and make on new message generated, and we want to notify the backend that this user is connected. So we will create a signal message model, and the command of it is equal to user connected, and the data is going to be sender user ID, and the sender is going to be sender username. So up here, we want to use this init remote RTC clients. For the sender user ID, we will pass user ID, and for the username, we'll sender username. So right here, let's actually add a log and check if the state of our peer connection is being connected to the media server. Okay, so after initializing the remote RTC clients, now it's time to use the message and check if the CP is not null. It's time to use RTC clients and use on remote session received and use it, and use to WebRTC session description, which is living inside this media server message model. It will use the type and check if it's offer, make it offer, and if it's answer, converts it to the answer. And next, using message.candidates and the for each function and use ice, we simply use the RTC clients and on ice candidates received function, pass it to it. And we also have to convert to WebRTC candidates. And after receiving the offer, we want to answer it. So we simply call the answer and pass the message.id to it. And down here for the destroy function, we simply want to let go with the media server. Simply use the close and RTC clients dot on destroy function for it. Let's go back inside our view model. Now it's time to connect to media server. So let's create a variable private var StreamPublisher. So it's the helper class for our publishing stream, and it's going to be null initially. We will make sure that it's the class that we are making. So inside this function, we want to instantiate it. So StreamPublisher is equal to StreamPublisher. We will pass the WebRTC factory JSON. Don't we have JSON here? No, we don't. Let's add private val JSON of type JSON. JSON. And for the callback, we use the anonymous class, StreamPublisher class, and use the StreamPublisher callback. Let's implement it. So we want to check the logs of new message model. And then after creating this, we want to use StreamPublisher start publishing. And we give local user ID and local username. Simple as that. So let's go ahead and test this one. Let's write one for room and also for the username. We can see the signaling server is connected. We are trying to connect to the media server. We simply connect it, and then we published the signal to the backend that says that, hey, user connected, which is us, with the user ID of 1 and the concatenate string to it, and the sender or the username that is us. Pretty straightforward. Let's move to the next video and explain how to now add consumer for the publishers inside this meeting. So till the next video, see you everyone.